Pyramid, Assistant Professor, Department of Mathematics, Dr. SNS, Science, Biology. I welcome to this video lecture. Now, in this session, we are going to discuss about the problem based on transportation problem. So, first, what is a transportation problem? Suppose here there are some A supplies and there is some PJ demand, and there are some of the costs are given. So, it is C11, C12, C13, etc., C19, and C21, C22, C23, etc., C2n, and so on, Cn1, Cn2, Cn3, etc., Cn. These are all the costs. We take the amount of supply using this unit cost of the transportation. It changes all the supplies through this cost and fill all this demand. So, in order to say the total transportation cost is minimum, that is the purpose of this transportation problem. So, we solve this problem using different methods. One is called the northwest corner rule, another is least cost method, and the third one is a workflow approximation method. Before that, what is feasible solutions? So, we transfer all the supplies using this unit cost, and among this all the unit cost, we choose a minimum cost and transfer all the goods from the destination to origin, from origin to destination using this cost. It is minimum. So that is the feasible solution. So first we check whether the problem is balanced or unbalanced. That means the total supply and the total demands are equal when the given transportation problem is balanced. If it is balanced, we get a feasible solution. And if it gets a feasible solutions, then we check it what is degenerate or non-degenerate. How we identify degenerate or non-degenerate? We use the transportation cost using this minimum cost. We have some of the minimum cells and occupy the cost through the cell, the number of cells. How many number of cells? It is equal to m plus and minus 1 formula. M is number of rows, n is number of columns, minus 1. If these two are equal, then the problem is called non-degenerate. If it is non-degenerate, we get a final solutions. So that is introductions about this transportation problem, and we got the problem based on this transportation problem using by one of the method is we got the initial basic feasible solution using northwest corner rule. So how solve this transportation problem using by this northwest corner rule? But using this northwest corner rule, we find the initial transportation cost and what are the basic feasible solutions. We discuss all this through this one problem. Here the number of supplies are 30, 50, 20 and the demands are 20, 40, 30 and 10. First we check whether the supply and the demand, these two are equal or not. So what is total supply and the total demand? We check it is the total supply is 100, likewise the demand is also 100. If these two are equal, then the given transportation problem is balanced. So if it is balanced, there exists a feasible solution. So first we check whether it is balanced or not. So sum of A means the supply. So it is A, the total supply, and the demand is some PJ. If these two are equal, then it is balanced. So some PJ. Therefore, the given CP is, the given transportation problem is balanced. So if it is balanced, therefore there exists here feasible solution. Okay, if it is feasible solutions, then we find the initial basic feasible solution using this method is called a northwest corner rule. So first we fix a figure. Now apply the northwest corner rule along this order. See, it is north, its direction is north, and it is west, it is east, and then it is west, is south, north, south, east, and west. So this corner is called the northwest corner. So among these all the cells, the northwest corner cell is this one. So corresponding supply is 30 here, and the corresponding demand is 20. So we take 20, we fill the 20 demand using the 30 supply. Therefore take 20 items or 20 product and transfer through this way, and then we fill it as 20. So here we take 20 and transfer that and then fill this. So still we have 10 supplies available. Through this way there is no demand, therefore we block these remaining cells. Next northwest corner cell is this cell. Corresponding supply is 10 and the demand is 40. So just here we have only 10 supplies available. So take all the 10 and fill this demand. So we have 30 demand is there. From that there is no supplies available, so block this. remaining northwest corner cell is this cell. Corresponding supply 50, demand is 30. So from that we take 30 supplies or 30 product and transfer here. Then still we have 20 supplies available. From this way there is no demand is there, so block this. Next northwest corner cell is this cell. Corresponding supply 20 available, demand is 30. So we transfer 20 supplies and just we fill that, still we have 10 demand is there. From that there is no supplies available, so block this. So remaining here we have 20 supply is available, but we need 10 plus 10, 20 demand is there. So split this 20 by 10 and 10 and transfer each. So cancel it. It's called a rim satisfaction. Okay. Now how many basic cells? 1, 2, 3, 4, 5, 6. 6 basic cells, or it is called occupied cells. First we check whether it is non-degenerate solutions or not. How we check it? The number of basic cells and is equal to the m plus n minus 1 formula. So the number of basic cells is 1, 2, 3, 4, 5, 6. But what is our m plus n minus 1? M plus n minus 1 means m is number of rows. Here 3 rows, n is number of columns, 4 columns. So 3 plus 4 minus 1, that is equal to 6. So the number of basic cells also equivalent to m plus n minus 1. Therefore we get non-degenerate solution. Therefore non-degenerate solution. Okay, what is the initial basic feasible solution? IBFS. Initial basic feasible solution means where this cell. The first cell is in first row, first column, it is 20, and second cell is first row, second column, so it is 10, and then the third one is second row, second column is 30, and then second row, third column is 20, then third row, third column is 10, and third row, fourth column is 10. So these are our initial basic feasible solution. Finally, first, what is initial transportation cost? Initial transportation cost. That means there are 20 product transfer from this way. Each product have 1 rupee. So total we had 20 rupees. So 20 into 1, 20, and it is 10 into 2 is 20 plus, and there are 30 product transfer. Each product has 3 rupees. So the 30 into 3 is 90, and next is 20 into 2 is 40 plus 10 into 5 is 50, then 10 into 9 is 90. So totally we have 310 rupees. So in this northwest corner rule, we satisfy the real conditions and we check whether the given solution is degenerate or non-degenerate using by the conditions number of basic cells is equal to m plus n minus 1 formula. These two are equal, then we get a non-degenerate solutions. Then we get what is the solution, that is where the occupied cells, that is our solutions, and what is the initial transportation cost. So using this way we get the initial transportation cost is 310. So that's all we discuss this case, and in the next video we shall discuss another type of a transportation problem to find the initial transportation cost by least cost method. This is the next video.